Hello, my name is Kristina Raygoza, and today I will be talking about attachment strength of Salmonella enterica serovar Newport and Listeria monocytogenes on melon hybrids from 5 growing regions in the United States. There has been a growing and ongoing concern in food safety due to the rise in contamination on melon rind surfaces. The pathogens may attach to the melon rind, and once they've attached, the pathogens are difficult to remove, and that can lead to foodborne illness. A few outbreaks where these pathogens have been seen as problems have happened recently. There was an outbreak in 2021 with the pathogen Salmonella branderup that happened in the European Union, and they suspected that it originated from Gallia melons. This outbreak made 343 people ill and 68 people had to be hospitalized. Then there was an outbreak in 2018 with Salmonella that was associated with pre-cut melon, which made 137 people ill and 38 people had to be hospitalized. Lastly, there was an outbreak in 2011 where Listeria was the pathogen of cause, which made an estimated 147 people ill, 33 deaths, and 1 miscarriage. There are several ways in which the melon rind could become contaminated on the farms, such as via contaminated irrigation water, contact with contaminated soil, and they can also become contaminated during the processing and washing of the melons. The farmer could benefit from the evaluation of the melons for their attachment strength by being able to select melons which could be more resistant to bacterial attachment. In turn, that could potentially lower the risk of foodborne illness outbreaks and costly recalls. For this experiment, our objective was to evaluate how strongly Salmonella and Listeria attach to the melon rinds of various melon hybrids to compare between the two pathogens, as well as the variety of melon. The method on which we were able to test for attachment strength was that we first started off by cutting out melon discs from each melon using a cork borer. After that, the melon discs were then inoculated with S. Newport or L. monocytogenes and allowed to sit for 30 minutes in a biohood to facilitate bacterial attachment. Planktonic cells that are not attached are removed by being placed in sterile PBS solution. Next, the melon discs were vortexed with 25 milliliters of 1 times PBS containing 0.1% tween to remove the loosely attached bacteria. The discs were then sonicated in 25 milliliters of BPW for 2 minutes to try and remove the strongly attached bacteria. Lastly, the PBS and BPW solutions were serially diluted and plated. The method used for calculating attachment strength was determined by the ratio of strongly attached bacteria to the total number of attached bacteria. For the results, Table 1 shows the attachment strength values of both pathogens for various melon hybrids in the 5 growing regions. While in Figure 1, it shows the attachment strength averages for the TH melon hybrids, and in Figure 2, it shows the average attachment strength for the S melon hybrids. On average, we saw that SMA, as shown in Figure 2, showed the lowest attachment strength average for Salmonella at 0.22. While TH9, as shown in Figure 1, showed the highest attachment strength average for Salmonella at 0.40. The average attachment strength for Salmonella Newport on all melons was 0.29, and for Listeria monocytogenes, TH1 showed the lowest average attachment strength at 0.22, while TH12 showed the highest attachment strength for Listeria at 0.42. The average attachment for Listeria monocytogenes on all melons was 0.29. SEM samples were taken to conduct further testing to measure the surface roughness on the outside of the melon and how it can correlate with how well the bacteria attaches. The results suggest that certain melon hybrids may have a lower attachment strength than others for one or both tested pathogens. Therefore, there is no significant difference in attachment strength between both pathogens on melons. And in conclusion, there needs to be some effective interventions for melons, since foodborne pathogens are able to attach in various capacities to the melon rinds. I would like to acknowledge Dr. Ravashankar, Libin, Richard, and Catherine with all your help in making this experiment possible. Thank you.